Okay, so in the previous session, we talked about VMs versus containers, what are C groups and namespaces, and a very basic introduction to Docker, right? Okay, so today we will continue with the architecture, the difference between images and containers, what are container runtimes, okay, and how do you install Docker, right? So what are Docker images and Docker containers? Okay, so first of all, what is a Docker image? Okay. So basically, Docker image is nothing but a package. Okay, it will have your complete application and all its dependencies, right? Okay, so it won't have any operating system. So guys, kindly mute yourself. So it won't have any operating system as such. Okay, so Docker image will have only your application, plus all its dependencies required to run that particular application. Okay. And there is also a base layer, which I will talk about it in some time. Okay, or we will cover that in the in the demo sessions. Okay, so that is a complete Docker image. And once it is created, you cannot modify it, or you cannot change it. Okay, of course you can create a new image, but once a particular Docker image is created, it becomes immutable. So which means a container cannot change that particular image. Okay, you can create a new image although. And every Docker image will have a very base OS layer. Okay, so this is where people get confused. Okay, so we say that image doesn't have any operating system. But what is this OS layer again? Okay, so let me tell you, by drawing. Okay, on what technology Docker works, or what is the virtualization technology that Docker uses? It uses OS virtualization, right?
Yeah,
Correct,
Linux
guys?
OS. Yeah.
Okay, so you have your hardware, and on top of it, you'll have your operating system. Okay, so I'm assuming it as Linux. And on top of it, for creating containers, you should have Docker installed. And within this machine, you can create any number of containers. Okay, so before creating a container, you should have a Docker image. Okay, that Docker image is nothing but it is a package, so that will have your application. Okay, so no source code, guys. You should not put any source code or leak any sensitive data or put any sensitive data within the image. Okay, and no source code. It is only your final application and any of its dependencies. Okay, so let's say I'm running a Python based application, and that Python based application so requires let's say Boto 3 you know module. Okay, so that is the dependency. Apart from that, you will have a very base OS layer. So why this OS layer is required? Because we said that containers are using the underlying operating systems a kernel. Okay, but the thing here is we are just using the kernel. Okay, so which means all your Linux kernel is available to all the containers. Okay, so what are containers is they are nothing but, if you have an image, you can create a container. So for time being, just assume that image and container both are same. Okay, so when the container uses the kernel, it gets the ability to run any process. But the thing is, if I'm running Python, okay, Python is an application. If Python is not available, what will happen? Your application won't run. So will you install Python in your operating system here? It's not required because that level of dependencies. So we will install it here. Okay. So your container will only use the kernel. But apart from that, whatever packages, softwares you require, you put it in the image itself. Okay. So let's say I'm running Java based application. So you don't have to have Java installed at the host level. You need to make sure that Java is available here within the image. Okay. So that is your Docker image. And always remember, a Docker image will have a lot of layers. Okay. So what are these layers is they represent something within that image. Okay. So when you're building a new Docker image for your application, uh, the first layer can be your base OS layer. Second layer can be any dependencies. Third layer can be your actual application. Okay. But we don't understand or worry about these layers, but understand. So Docker image will have series of layers. Okay. And we can store these Docker images in registries like Docker Hub or ECR. Okay. You can host your own Docker registries like Nexus, JFrog Artifactory. So all these can store these Docker images. Understood? So having a Docker
So,
image,
yeah, sorry. So base OS is required because we need to install other dependencies or other libraries in the image or in the container,
yeah.
or any other reason.
No, that's the only reason. If you're working on Java, you should have Java.
No, Java is fine. Base OS.
So that is the thing.
Okay.
So
So
base
in
OS
order
means it
to,
is not Ubuntu or it is not CentOS or it is not full-fledged operating system.
yeah, yeah,
These
it's
are
it's
all the dependencies that are required to run your application, apart from the app level dependencies. So what are system level dependencies you need?
oh, in order to put all the system level dependencies, we require both base OS in the image, and we'll pile up the.
Yeah. So let's say, instead of this Python, let's assume it is a shell script. Okay.
Yeah,
So the shell script requires a command known as probably, I'm assuming tree is the command.
this copy. Okay.
Okay. So the tree command is not available here. You know, it has to be available here. So what we need to make sure? We need to make sure that
Not
the
able
tree
to see
command
your,
is
not able to see your cursor. Yeah.
here.
Yeah. Now. Yeah.
Okay. So it has to be available here.
True.
Okay. So you'll understand it. Just one day, one more day. So after that, when we dive into practicals, you'll understand everything. But for now, just assume that OS means not full-fledged OS, but any required dependencies to run your application.
Yeah.
Okay.
Understood. Yeah.
And coming to the containers, so these are actually runtime instances of your images. Okay. If you have an image, you can create a container out of it. Okay. It is just like you have a blueprint of a particular, building, and you're actually creating various instances of those buildings using that blueprint. You can create any number of containers from a single Docker image. Okay. It is not like you have created, you guys are working on a web application, okay, based on Go. Okay. And so what you have done, so locally you have developed that Golang application, and now you wanted to run it in the form of a container. Okay, so now you have containerized that particular application in the form of a Docker image. Now, using the same Docker image, you can create any number of containers. Okay, and we need to remember one more thing here. A container, even though it is created from an image, cannot alter the image. It cannot, change the image, you know, go and change a file, modify a file, delete a file. So it can't actually do anything to an image. That's the reason we call it as immutable. Okay. A container, even though if it is created from the image, cannot alter the image. Of course, as a user, you have the ability to modify the image, generate a new image. It is up to you. Okay.
But the container can be changed. Right?
A container can do anything. Okay.
So it is
So
a read-only copy. Image is a read-only copy.
image is a read-only copy. Container behaves little differently because container means it is your application. Okay. So your application should have the ability to change anything.
Right.
But how it manages the change without impacting the image is what we see in Docker volumes. Okay. As we already discussed, containers are nothing but, even though we say those are runtime instances of a Docker image, okay, so these are nothing but a series, a set of processes running in an isolated environment. Okay. You know, Docker creates these containers using namespaces and C groups, concept in Linux, as we already discussed, which means, okay, so if I have to explain, using processes, so the image that you Dockerized, I mean the Golang application, so it will have a process. Okay, so that is the process that actually starts the web application. Okay, so when you create a container out of that Docker image, okay, so that particular process will be in the running state now inside it. Okay, now this whole concept of container, we already discussed, is based on namespaces and C groups in Linux. And these containers are also known as isolated environments, or you can also call it as these are instances of a Docker image. Okay. Now, if I have to compare the VMs versus containers, okay, every VM, will be created on top of a hypervisor, and every VM is isolated, but the problem is they have their own operating system. But when we talk about the containers, you know, the hypervisor is now replaced with the Docker engine, okay, which is acting like a hypervisor, creating a lot of containers. But the thing is, we don't have a dedicated operating system inside each container. Okay, so which means containers are very lightweighted. They take very less time to start and stop. Okay, so that is the only difference. Okay. And then there is another difference here, if you like to know. So you have your physical host, you have your kernel, you have your operating system binaries and all. And then you have the virtualization layer created using type 1 or type 2. And inside VM, if you see again, they have their own guest operating systems. But the same is not true in case of, your Docker or container architecture, where the Docker engine is responsible for creating a lot of containers, but none of the container has their own operating system. Okay, because they are using underlying host machines operating system. Okay, so that's the reason it is OS virtualization. And the other difference, which we already talked about, if you're on a VM, okay, any process runs inside a VM, okay, is not visible to the host operating system. Okay, so host cannot see all those processes. But any process runs within your container is visible to the host, because it is OS virtualization. So OS sees all those processes running inside all these containers. Okay, clear? Now this is just a simple example. I'm going to come back to this again later. Okay, I just want to show you, how that really works. Okay, so here what I did is I created a container. Okay, so don't worry about this command. It's very easy. Okay, I created a container. Inside the container, there is a process running. Okay, so the process running inside the container is, I'm showing it here. Okay, as we already discussed, every container have a starting process of one, PID of one. So that PID of one is nothing but it is starting a bash process inside a container. And we already discussed any process running inside a container visible to the host. So if I check this process, okay, inside the container, it is one, PID is one. That same PID, if I have to check inside, outside the container at the host level, the PID is 1562. Okay, this is PID mapping. So at the host level, if I just do kill -9, and if I do 1562, what will happen?
And that container will get
That
closed.
container itself gets closed because we are actually closing that root process. I mean, the starting process. Okay. So you can also do this once you have enough knowledge on how to create containers and all. Okay. And coming to basic differences, VMs have hardware level virtualization or hardware virtualization because they share host resources like CPU, MEM, and storage. but containers are OS level virtualization. They have huge maintenance costs because you have to pass the operating system running inside guest machines and all, but there is little maintenance, little to no maintenance in containers. Scalability is hard because every VM takes a lot of time to, start and stop. So guys, please mute yourself. It gets recorded in the session. I can't block individual. I can't mute everyone. Okay. And containers are easily scalable because they don't have any OS. They are very lightweighted. They can be easily pulled from registries and started instantly. Okay. So these are various differences that you can pause this video and see. Okay. Everything we have
Vikram,
discussed.
You said CMAPs are used to allocate the resources or system resources.
Yeah.
So it is using the host resources, right? Hardware resources like allocation of RAM or allocation of processor capacity,
Yeah.
etc. etc. So container also using the, I mean, is it again a hardware level virtualization?
Yeah. So container also takes, the resources from the hardware only. But here we don't have any OS. It is OS level virtualization.
Sorry,
Okay.
can you just explain me once?
No, container gets the OS and also the hardware resources directly from the host.
Right. Even
Okay.
in VM also same thing, right?
But in VM, we have operating system, a separate operating system inside each VM.
Yeah, that's true. Since it is directly taking from the host OS, we are saying that it is host level virtual.
Yeah,
Okay,
correct.
fine. Thank you.
Okay. And coming to the Docker architecture, okay. So when you install Docker, right? So there will be, a couple of components installed. Okay. So one is Docker client tool, also known as Docker CLI. Okay. So it get installed with a name called Docker, no CLI, nothing like that, but it is a client tool. And you have a daemon process. Okay. Also installed. So we call it as Docker followed by D. So it is called Docker D. Okay. It's a daemon part. Okay. So when you install Docker, both gets installed. So can you install separately? Yes. You can go to the download page and then install client separately, daemon separately. In case, if you want to, talk to a remote daemon and all, okay, which we will see uh, probably later if it is required. Okay, but the thing is, if you install Docker within the same machine, you'll have the client and the server. So we call it as a server. So Docker follows client server model. Okay, where client is required to talk to the server. So do clients, do server require a client to get instructions? Of course, it is not required. The thing here is, in order to talk to the daemon, you should have enough knowledge on how to form the command, okay, and everything. So it is not easy to remember or understand all those high level API calls and all. That's the reason every tool will have a client. So where you run commands in plain English language, and that gets converted into a language which is understood by the server. That's the reason why we have client tools. Okay. And of course, any Docker, any DevOps tool or any tool, okay, should have the capability to get integrated with the other tools. Okay. So when we talk about microservices based communication, we said that each microservice can talk to the other microservices using REST API of that particular microservice. If A and B are two different microservices, A uses B's REST APIs and B can also use A's REST APIs to communicate. Okay. Similarly, the client also uses the APIs of your server or the daemon to talk or to send commands to the daemon. Okay. So commands like creating an image, creating a container, creating a volume, it can be anything. Okay, clear?
Yeah.
So on the same machine, there is no networking involved because they are both on the same machine. But sometimes you get this use case where probably your Docker client is installed in your local Mac or Windows machine, but your Docker daemon is running somewhere in EC2. Okay. How do you manage? How do you, establish client to server communication? Because client always looks for the server on the same machine, but now client has to be configured so that it finds a daemon running somewhere remotely in an EC2 instance or somewhere. Okay, so that is again another, configuration that you can do. Okay, that's the reason why, the client can talk to the daemon using two protocols. Okay, so one is a Unix socket. Okay, so where, this client can talk to this server within the same machine. Okay, so we will see what is this Unix socket, the location later. And the other is TCP socket. Okay, so what is TCP? It is it is a networking protocol, right? Correct. So
Yeah.
why TCP is required is when you have client and server on different machines and you want to establish the communication through the network using TCP protocol. Okay, so the default is always Unix socket, but it is possible to configure TCP communication between client and the server. Okay, and Docker registry usually is not part of your installation, but the daemon, if it has to download images or store the images to registry, it can do it. The standard or the default registry is Docker Hub. Okay, from where you can pull all the standard images and store your images. The problem here with Docker Hub is you can't store images privately. Okay, you have only one private repository. Sorry, you can store only one image in private mode. Okay, if you have to store second image in the private mode, you can't do it. You have to buy some subscription. That's the reason why, in order to protect your Docker images, you should set up your own Nexus or JFrog or any artifact tools. Okay, within your organization. Okay, you can't rely on Docker Hub, but of course, Docker Hub will have all standard compliant Docker images from all the organizations. But if you configure or if you create your own custom image for your internal applications, make sure that they are not available on Docker Hub. They are stored privately within Nexus or JFrog within your organization. Okay.
Yeah. 1 minute. Vikram, in the previous slide, you put images and volumes to, yeah. So they will be using it. They will not managing them, right? Docker daemon.
Both. It's a complete life cycle.
So it, I mean, images it manages means you are saying that it can create images and as well as
Yeah, it
delete
creates
and
images, deletes, creates volumes, uses, deletes, containers, creation, deletion, modification, everything.
okay, even volumes also.
Yes.
Okay, I thought volumes are from OS level
No,
stable
no, no,
volume.
no, no. That's why, you just wait because we haven't covered anything yet.
Okay, okay, no problem.
Okay. And, these are, various images I've just taken from internet, all are same. Okay. Same daemon. Uh, you have a client tool and the client talks to the daemon over the REST APIs, as we already discussed. Okay, you can also, write some programming using Python or Golang, and you have the ability to talk to the daemon programmatically, bypassing, see, when we talk about daemon, we are actually not talking about the daemon. Okay, we are using the daemon's APIs. Okay, so you can write any automation script, okay, to directly talk to the daemon bypassing the client tool if you know how to use Docker's REST APIs. Okay, so that is one thing. Docker client also you can do, but it is an extra, tool that you will be using. So if you know how to use REST API, And if your programming language knows how to call a REST API, so why would you again go back to the client and then come back to the daemon like this? It is not necessary. Okay, that is about Docker architecture. And Docker registries, as we already discussed, it is a place where we store all the container images, not the containers. And the default, by default, Docker engine or the Docker install interacts with Docker Hub, which is a public registry. Okay, you can create your own account and you can store your images, but mostly they will be in public, which everyone can see and download, but only one image can be in the private mode. Okay, but there are other options as well. You can use cloud specific registries like Amazon ECR, Google Container Registry, that is GCR, or Azure Container Registry, ACR. There is also known as Squai .io from Red Hat. So there are a lot of container registries. So if you try to set up Kubernetes or any tools that runs on Docker images, you will see that those tools try to pull images from either Docker Hub or their own registries, or GitHub has its own registry from where you can store your container images. Okay, so there are a lot of places you can store, but remember, all of them will be in the public, which everyone can see. Okay, so now we talked about Docker, as a tool for creating the containers. So are there any other tools that can create containers, right? So this is what we need to know. So before understanding that, we need to understand what is a container runtime environment. Okay, so what is a CRE? Okay, so Docker is one tool. Okay, so similarly there are other tools, but so internally what these tools do? Okay, because we cannot directly create containers ourselves, right? Without having enough knowledge on C groups and namespaces, it is very hard to create the containers. That's the reason why we are relying on tools like Docker. Okay, correct? So Docker, creates these containers in an isolated environment and everything which we already discussed. Now, what is a container runtime is, container runtime is a software that we install in any of the host machines for running, managing, creating, stopping, and all those containers. Okay, because we cannot create C groups and namespaces, and we cannot control containers creation, deletion manually. So we use container runtimes. So Docker is one container runtime that manages your complete container lifecycle. Similarly, you have container D. Okay, we have Cryo, you have RKT. Okay, you can use any of these tools to create a container. In fact, you can create a container image using container D, but run it with Docker, because all of these follow a standard specifications set forth in OCI. Okay, open source, open container initiative. Okay, there are some standard set of guidelines that every container runtimes should follow. Okay, so if they follow these specification, so what is the advantage we get is, you know any image that we create with a container runtime can be run with other container runtimes, because all of them are following the standards. Okay, got it. But if you look at the Docker architecture, okay, so Docker is a very high level component. Okay, but internally it is using container D, which in turn is developed by Docker itself. So container D is the actual daemon. Okay, so which is responsible for managing the containers. Okay, and again internally container D is using a component known as RUNC, and RUNC uses C groups, namespaces, and other things, to create the containers. Okay, so you have a low level component, you have a high level component. Okay, like container D. Okay, but why again Docker on top of a container D is, Docker came up with own set of tools like Docker APIs, Docker CLI, Docker, server component, and all these together we call it as Docker engine. Okay, so here This container D, is a core component or high level component that is actually managing the container lifecycle. But on top of it, you know, you are actually having Docker. Okay, but when you install Docker, container D gets installed, RUNC also gets installed, everything gets installed. In fact, you can just install container D and work with your containers, like creation of the container, destroying, creating images. You can also do that, but you will lose other abilities of Docker, like you won't have Docker client or Docker networking and all those things. Got it? Okay. So if I have to, differentiate between RUNC and container D, okay. So RUNC is a runtime, but it is a low level container runtime, and it follows, open container initiative specifications for creating containers, running them, creating the images, etc. But container D is an actual daemon process. Okay. So where RUNC creates containers, okay, but there should be other component responsible for creating Docker images, pulling the Docker images from the registries, storing them back to the registries. So that complete lifecycle is managed by container D daemon. Okay, so it is acting like a high level abstraction, and Runk is a low level abstraction. Okay, so Runk knows how to create containers using C groups and namespaces. So which means if I write a command to create a container, that command first goes to container D, and container D, make sure that the image is available. Then container D instructs Runk, which is a low level component, to create container for you. Okay, so if you take this as a Docker CLI, I just run a command to create a container C1, that goes to the engine. So this client tool uses REST APIs of Docker engine, and the Docker talks to container D for creating the image container. Now container D sees if that particular container image is there or not, otherwise it will pull it. And once it has the image downloaded, again it instructs the RUNC to create that container for you. Okay, got it, guys? It is on a high level. This is not required, but it is good to have this minimum knowledge, on how the command flows from CLI to RUNC. Okay,
So Runc is like it will only create the containers, right?
right. Yeah. So RUNC is the component that ultimately creates and manages the containers. But container D has other features like pulling the images, creating the custom images, and all the other features are there.
So
Okay.
run C can also be isolated installation can be possible for run C.
No, Runc only uses C groups and namespace to create the containers.
Yes,
So
yes.
it is actually the core component which can actually run kernel related commands.
Right, right. No, no. You said a container without Docker also we can just install the container D.
Yeah, correct.
So likewise, just run C can also be installed.
Yeah, Runc can also be installed. See, every of these components, right, they are open sourced. Okay. So if I just type, GitHub RUNC, you can see here RUNC can be downloaded and installed. And within the repository, you even have the commands, to uh, run containers, create containers, list containers, start a container, delete a container. It has everything.
Okay,
Okay.
understood. Yeah. So everything is componentized, and you can
Yeah. So
install
the
them.
reason why it is all component wise is in case if container D, if any other tool wants to directly communicate to container D. Okay. So it need not has to go through Docker and then go to container D. Okay. So in order to have that, pluggable architecture, so where you take a component and then you can connect to the other component easily. So you have this kind of, architecture.
Okay, it is like a microservices.
Yeah,
Yeah,
kind of.
And
understood.
which is responsible to pull the Docker from registry, like
Container D.
content.
Okay.
And you
So
mentioned the custom image creation also part of containerd, right?
yes, because containerd is the core component. So if you look at containerd, it is it is developed by Docker itself. And on top of it, Docker has its own CLI, UI. Okay. I'll show you when I install. Okay, so now this is donated to CNCF. Okay, so it is a CNCF project maintained separately. But this is initially developed by Docker itself. Okay, and then it is donated to CNCF. CNCF maintains it. Okay, you can see here it is responsible for creating the images, managing them. Okay, so there are a lot of things uh, it would do.
Okay.
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 So, but these are something which you don't have to, worry about because, we don't directly interact with containerd. Okay, we always use Docker CLI commands. Once you're comfortable, you can explore all the other things. Okay.
Yeah, sure.
Now coming to the Docker installation, so you can install Docker on all three operating systems like Mac, Linux, and Windows. But in Windows, it is a little bit tricky because, you know, if you don't have Windows 10 Pro, you cannot install, Docker. So you should rely on tools like Windows Subsystem for Linux to install Docker. Okay. But for Mac and Linux, you can directly install them. Okay. So there is no restriction. There is an also online emulator. If you open this link, you can log in with your Docker Hub account, and then you will have 4 hours of free, 4 hours of time to use a VM inside this where you can run all the Docker related commands. Okay, but highly suggest not to use this. Okay, you should set up your own Docker instance. Okay, for Linux, Mac, it is pretty straightforward. For Windows, that is the only problem we have. Okay, so if you don't have Windows 10 Pro, you should enable Windows Subsystem for Linux and then run Docker. Okay, so I have Windows 10 Pro and I have installed Docker in my Windows. I'll show you how that UI looks like, how Docker is different from containerd and all those things. Okay, so this is a small flow chart, you can say. Okay, so if you have Windows 10 Pro or Enterprise license, you can use Docker on Hyper-V because Windows 10 Pro gets type 1 hypervisor, so you can easily install Docker. But if you don't have it, okay, what you should do is you should enable Windows Subsystem for Linux and then install Docker for Windows. Okay, so that is the only option you have. But for Mac and all, it is pretty straightforward. Okay, I'll go to the official documentation. Still, we haven't, started looking at it. Okay. And installation on Linux, it is pretty straightforward. Okay, you just have to run a command called yum install docker-y. That's it. Okay, it will automatically install Docker. And then once you have the Docker installed, you can check the status using systemctl status Docker. If it is not started, you just do systemctl start Docker and you enable it to start at the boot time using systemctl enable Docker. Okay. And then there is a group called Docker group, and you need to add users to the Docker group, which I will talk about once we install. But just remember, installing Docker is, pretty straightforward. Okay, now let's go to the uh, Docker homepage. Okay. Or else let me, okay, it came. So you can go through this document, go through this web page. And once you're done, you should come back to developers and then docs. Okay. So this is the page you need to refer throughout our Docker sessions. Okay. You have get started section, download and install, guides. Okay. Um, language specific guides, manuals and references. So in the getting started, you will have very basic introduction to Docker, what is a container, run a container, okay, and how to deploy multiple containers at once. So you can go through this guide later. It's not required. And download and install is one part where you need to refer instructions for installing Docker. For Docker, Docker installation in Mac, it is pretty straightforward. You'll just download the binary file and you install it. For Mac with Apple Silicon, this is the installation. This is the binary file. Just click on it and it will automatically download that file. And you have to install it. Okay, you will have .dmg file downloaded. Just double click it. Okay, it will automatically install. Okay, and once it is installed, it won't start. You need to start it. Similarly, Docker desktop for Windows, it is the same thing. But the thing is, either you should have WSL2 enabled. Okay, all the instructions for turning on WSL are mentioned here. And once you have that installed, you can install Docker. Okay, or for Windows 10 or Windows 11 Pro, so they can directly install Docker by downloading it. Okay, so here, so where is this? Here, Docker desktop for Windows. Okay, so there is this WSL backend and Hyper-V backend. Just click on this and it will automatically install. Okay. And coming to Linux, it is little different. So you have for Ubuntu, Debian, and Fedora. Okay, for Fedora, okay, you can install Docker using, first you need to add a repository and download the RPM packages and install them. Okay, so all the instructions are given. So I'll just talk about installing it in our EC2 instances. Okay, got it. And once you install, right, so you will have a home directory for the Docker. So what is home directory? So it is a place where Docker stores all its data. Okay, like a normal Linux user gets a home directory under /home. Docker also gets a home directory under var lib docker. It is not /home/docker. It is var lib docker. Okay, inside this only it is going to store all its data related to containers, volumes, networking. Okay, so all these things it is going to store here itself. Got it? Okay, now let's quickly install Docker, and after that probably I'll also show you how Docker desktop looks like on Windows. And going back to this Docker docs, you also have guides, okay, which you can follow. One thing that you need to uh, you know implement after the Docker is Dockerizing all these applications. Okay, so you have Node.js based applications, Python, Java, Go, and you have a step-by-step tutorial for containerizing a Node.js. Of course, I'm going to teach. Okay, but you should also practice. So you should practice how to Dockerize a Python, Golang, Node.js, Java-based application, PHP. PHP, Rust, and this .NET are not required, but at least concentrate on Go, Java, Python, and Node.js. Okay, you should know, what all things you require for Dockerizing an application, how to Dockerize it, how to reduce the size of the Docker image, and all those things. And finally, in you have the reference here. So this reference is for all the commands. Okay. So if you see, you have the references to the Docker file, references to the daemon. Okay. If I just click on the CLA reference, you can see all the commands. Okay. If I have to start a container, what command I have to run? Okay. Docker start. Okay. So what are the various options supported by Docker start? Okay. So all these are given here. Okay. And you also have Docker file reference. Like I need to build a custom Docker image. So how do I do it? So what are various options I have? So everything is given here. Got it?
Yeah.
Okay. So you need to follow this.
So
And not
here
only
Docker
this,
D is nothing but the container D, right?
yeah.
Okay.
So you have various best practices also mentioned here for writing a Docker file. In fact, in this session also, I'll show you some of the best practices. Okay. And then how to containerize various applications. Okay. You have self-paced tutorials, which you may not require. Okay. So make sure that, you refer Docker because, now Docker came up with its own container scanning tool. Okay, using called Docker Scout, which means, see, uh, you know 2 years back, Kubernetes deprecated Docker. So what Kubernetes deprecated? So does Kubernetes stopped using Docker, or what is that deprecated meaning? Okay, so deprecated meaning is Kubernetes is no longer directly using Docker, but it is using container D. So which means it is not interested in Docker networking, Docker volumes, and all those concepts, because Kubernetes has its own networking ways of managing networking, ways of managing the volumes. So it doesn't require Docker specific some features. That's the reason why what it did is it is directly integrating with container D now. Okay, but Docker will always be there. Okay, so this it is you know it is one of the best tool to create images, run containers, and all those things. Okay. Okay, which means there will be continuous development and new feature releases for Docker. Okay, so you need to check Docker documentation regularly. Got it?
So
Where are
within
the
this
best
dog,
practices,
dog.
Vikram? You showed us. I was
Sorry,
just step.
sorry.
You said there are best practices. Where are those?
Here.
Okay, I just stepped out of my seat. Okay, fine. Okay, okay, got it. Thank you.
Okay, so now what we'll do is we'll quickly install Docker. Okay, I'll take one EC2 instance and I'll call it as, okay, I can use anything. So let me use AMI Linux, Amazon Linux 2023 MI, which is free tier eligible. Okay, T2 micro is sufficient for me. And I'm going to select a key pair, which I already have. Otherwise, you create one and attach. Okay, it's a simple VM based on T2 micro. Okay, so let me SSH.
Is this putty Vikram or something else?
This is MOBA XTEM. Okay, so I logged into this EC2 instance. Okay, so first thing we do is yum update -y. Let me become sudo first. It's better. And then yum install docker -y. Okay. Okay, so Docker is installed. If I do systemctl status Docker, it is in the stopped state. Okay, so before that, so when I install Docker, right, you can see Docker install RUNC component. Okay, and also container D and other IP tables and all the relevant dependencies. Okay, so what we will do is we will start Docker systemctl start Docker, and we will also enable it to start at the boot time using systemctl enable Docker. Okay, and now if you check the systemctl status for the Docker, you will see that Docker is in the running state. Okay. And once you install, do check out Docker Home. Okay. So for that, if you look at etc password d file where you'll have information about, you know, all the users and all. Okay. So this is uh, password d. 1 second, let me. And if you check the etc group, you'll have a Docker group created here. Okay. And coming to the home directory, so always remember the home directories. So var lib docker, I will ask this multiple times, okay? Because it is asked in the interview multiple times. So var lib docker is the location where Docker stores all its data. So another question that usually get is, so this is a location on the machine, right? On the volume. So what if this volume grows and it completely consumes your disk space? What you will do?
We need to expand the disk size.
Yeah. Otherwise, you can do one thing. You can create another EBS volume, attach it, and you can move this complete data into uh, that attached volume. So which means valid Docker, even though it is called as a Docker home, it can be changed. Okay, you can create another folder and ask Docker to consider that as Docker home. Okay, you can easily do that. Clear, guys?
So if we lost this particular folder, so everything is gone, right?
Everything is gone. Yes.
But still the Docker will be running.
Docker will be running, but it won't. It is as
It-
good as starting with a plain installation of Docker.
Okay.
But anyway, see, these are all temporary, right? If you have the source code, you can create Docker image. Okay. If you
Yeah.
have Docker image in Docker Hub, you can pull it anytime. But the problem comes is if you are using Docker volumes to persist some data, and if that data is gone, you can't do anything. Okay.
Okay.
Yeah. So now this is a very basic installation of Docker. Okay. So we will see some commands. As I already said, Docker uh, is a client server model. Okay. So you have seen the server running, but client tool is Docker. Okay. If I just run this Docker command, okay. So it is giving you some options because this is a tool, client tool. Okay. So this is actually talking to the server and fetching the information back to you. Okay, the first command you should know is how to get the version. Okay, and for that you should know how to get all the list of available commands. Okay, you can simply do docker --help. Okay, you can see all the commands. Okay, so here Docker is following, this particular syntax. Okay, first is you have to use Docker keyword followed by the main command or the management command, and then you have the sub command. Okay, and after that you can have any number of arcs that are supported by this command. Okay, so if you see, we have Docker is it CLI, system is a main command, df is the sub command for it. Okay, like this. Now doing docker --help will give you, all the main commands. Okay, and all the sub commands are available here. Got it? If you see here, system is a main command. Okay, which means I can do docker invoke the main command. But if I don't know what all options or sub commands supported by this main command, I can simply do --help, which I usually do multiple times. Okay, now what command I have to use? Docker system, and the sub commands are 4 here. I can simply use info. So this will give me information about this particular Docker. Okay, like Docker is a client server model. Which version of client you are using? 24. Which version of server you are using? 24. Okay. And on the server side, which is the C groups driver, which is the logging driver, and your base operating system, its architecture, number of CPUs this machine is running, the total memory, the host name of this system. Okay, so where is the Docker home directory or root directory? It is var lib docker. So are you running this Docker in the debug mode? No. Okay, so all these are all this is the this is the basic information about your Docker installation. But let's say I don't want to see all this information. I just wanted to know the Docker version. Okay, simply to Docker version. So it will give you just the client and server versions. Okay, there is also a command known as Docker hyphen capital V, uh, no, small v. Okay, so this will give you the same thing. Okay, see here, for every you call these are flags. Okay, hyphen hyphen anything, if it is starting with hyphen hyphen or hyphen, so we call these are flag. Okay, so this is a long flag and this is the short flag. So for every long flag, there exists a short flag in most cases. Okay, and after Docker system info, you have other commands like Docker system df. So what is this Docker system df is? So it will show you how much of space is occupied by your Docker. Okay, it is not normal df command of Linux. It is for the Docker. Like I have these many images inside this machine, these many containers, these many volumes. Okay, so how much is the total space, so that I can easily see which images to delete and which volumes to delete. Okay, so df is disk free, but it is for the Docker. Got it? And then the other command like Docker system uh, events. So these are the events. Okay, so within your Docker system. Okay, so if there is any issue happening within Docker, so using Docker system events, you can see all those events here. Okay, currently there are no events. And final command is prune. So this prune is for the system. Okay, so Docker system prune. So prune is like deleting everything. Okay, you also have individual prune commands for images, containers, volumes. Okay, but Docker system prune is for the complete Docker. Okay, so when you execute Docker system prune, what this command will do is it will remove all the stopped containers. It will remove any networks that are not used by any container. It will remove all the cache within this particular Docker host. Okay, just to clean up your machine. Okay, got it? Let's say you worked on this Docker machine for like a month. Okay, you worked on a lot of container images and a lot of custom Docker files. Okay, so there is a lot of garbage inside this machine. Okay, and whatever Docker images that you have created, you have already pushed them to Docker Hub or some container registries. So you don't require any data in this machine. Okay, and you don't want to delete Docker. Okay, you just want to clean up Docker. You just come to this command, like you just do Docker system prune and everything will be deleted. Okay, so you can, in fact, you can also check if there are any sub commands or sub flags supported by this sub command. Okay, got it? See here, by default, Docker volumes contain the data which is required. Okay, so Docker system prune by default will ignore volumes due to security reasons, because your volumes data should not be deleted. But if you also want to include the volumes to be deleted, then you need to pass that flag as well. Okay, not only that, you also have you know hyphen hyphen null. So this will also delete all the images which are not dangling images. So I'll talk about dangling images later. Okay, even that option also is there. In fact, you can also use force. So this command will actually delete everything without any prompt. Got it?
What is the build cache here?
I'll talk about it later.
Okay.
It is like a normal cache because if you rebuild an image again and again, okay, so Docker need not, do that process again and again, right? Just like Maven dependencies, once a dependency is downloaded, why it will download again, right?
Okay. Yeah.
Let's say an image is already built, and if I again initiate a command to build it again, so why will Docker start from scratch? It will simply say that it is already built. So how Docker is able to say that it is already there? So it is able to compare with the cache.
Is it only for the images, or is it like if we already have that particular image, so in that case that we can call it as a cache, right?
So as the name itself indicates, it's a built cache. It is related to images.
Okay. Okay. Yeah.
Okay.
Thanks.
So this is how you have to understand Docker commands. Okay, so you just have to take a main management command. Let's say, a container. So container is a main management command. Okay, but I don't know any other sub commands inside that. Okay, you just do Docker container hyphen help, and let's say run. Run is a sub command, but I don't know how to use that command completely. So just do Docker container run and hyphen help. You will get that complete, syntax for Docker container run and all the supported flags. Okay, so all these flags are not at all necessary. Okay, if there are hundreds of these flags, we hardly use 5 to 10. That's it. All these are not required. Okay, any questions, guys? Okay, and before closing, I have to explain one more thing. So I install Docker as a root user. Okay, if I exit from root user and if I become normal user like EC2 user, so will I be able to run some Docker commands? Okay, just don't understand what is this Docker PS and all. Okay, just run this command as a normal user and see. You will get permission denied error. So why we are getting this permission denied error here? Okay, so here if you look at the error, it is saying permission denied when trying to connect to the daemon via a socket. Okay, as I already said, this client tool should talk to the daemon in two ways. One is either Unix socket or through TCP socket. Okay, Unix socket is used in case if Docker client and daemon are installed on the same machine, which is our current situation here. But your client is not able to talk to the daemon using this Unix socket, which is available here. Okay, so if I just do ls-l on that file name, you will see that it is a socket because it is S. Okay, and here this socket file is owned by the root user and by the Docker group, right? Got it?
Yes.
Which means normal user cannot access this socket. Either he should be a root user or he should be part of Docker group. So which is what we are going to do. So we are going to modify that user using user mod, add him to a group called Docker. The username is EC2-user. Okay, so user mod, adding EC2 user to the Docker group. Okay, so we have added it. Okay, so once we have added, we need to make sure that we run new group Docker command to update the group details for the current session. Okay, this is a mandatory step. Now if I do Docker PS, it should not throw me any error because this EC2 user. Okay, so if I just type groups command, you can see that this EC2 user is part of Docker group as well now. Since he's part of Docker group, he has ability to invoke this socket file, right? This is an extra step that you have to do for any user. If any user wants to talk to the Docker daemon, okay, he should be added to the Docker group. Got it?
Yes, sir.
Yeah. Okay. So this is for today. From tomorrow, we will be working with Docker images, containers, completely hands-on. So we are almost done with the theoretical part until we come to the other topic like Docker volumes and network. So for at least for a couple of days, we will talk about containers, images. Okay, so there are plenty of commands. Okay, you should know, and we use them on regular basis. Okay.